tool. So here we go. Let's start off by thinking about our classroom and bringing back that ratio from the first video about how many boys and how many girls there were in our classroom. You'll recall that we used this ratio in the last video. There were 4 girls and 8 boys. You'll probably also recall that when we were talking about the 4 and the 8, we said that these were the terms of our ratio. Now let's imagine for a second that I take my class online and I open it up to the entire world. And I go one day and I'm surprised to see that instead of 8 boys, suddenly there are 200 boys in my online class. And let's also pretend that I found out that the class grew proportionally, meaning that they grew at the same rate of boys and girls grew. You'll notice that I'm setting up a proportion here where boys is to boys and eventually girls will be to girls, but right now I don't know how many girls there are going to be in class. I haven't got those results yet, but I know I want it to be proportional. So the question becomes, how many girls will there be if there are 200 boys in my class? And when I don't know a value, what I'm going to do is use a variable. In this case, I'm going to use the variable x. Variables again stand for an amount that we don't know and could change. So here we are. We have our terms for our proportion set up. The only problem is we got to solve for that x and see what that missing value is. Now I know you guys can probably figure this one out in your head just knowing what you know from equivalent fractions, but I'd like to do this algebraically. And if you remember back in the ratio, proportion video, I showed you that if you cross multiply these terms and they come out to the same product, then you know it's proportional. We can use that little trick to our advantage to solve this problem. So let's go ahead and start cross-multiplying and see what we come up with. I personally like to get the ugly stuff out of the way first, so I'm going to multiply the 8 and the x. And of course when I do that, I'll get 8x. Okay? And then I'll just take down my equal sign, so then I'll bring that right down. And then I'll multiply my other two terms, the 200 and the 4, and 200 times 4 is 800. Okay, so now I have 8x equals 800. In other words, what that equation is saying is 8 times a mystery number equals 800. And I'll bet you know what that mystery number is, of course. But doing this algebraically, what we'll have to do is kind of separate the number from the variable. So if I divide this by 8, I'll get 8 divided by 8, which will cancel those out and it'll be 1. I'll be left with 1x. And we know that 1 times x is simply x. So that's nice. But when I'm working with equations, I always have to treat both sides of the equation equally. And so not only will I divide 8x by 8, but I'll divide 800 by 8. 800 divided by 8 is 100. And what I'm left with is a nice simple answer that x equals 100. If I substitute this x now for 100, oops, let me get my pen there, sorry about that. Substitute that 100 in for x, and now cross multiply, I'll see that they come out proportionally. 8 times 100 is 800, 200 times 4 is 800, and so I've solved using a proportion. Now there's this beautiful tree at our school, and I always wonder how tall it is. And being a math teacher, I can't let a question like that go. And I wonder if using proportions can help me figure out how tall it is. So how am I going to figure out how tall this tree is? And how am I going to use proportions to do it? Well, with proportions, we need to set up two ratios that have the same terms. So let's look at this tree. What do we have here? We're trying to figure out how tall it is. Is there anything else we notice about the tree? Well, I noticed that the tree is way too tall for me to climb it safely and measure it, but I also noticed that it has a shadow that I can measure. Look at that. All right, so now we're in business. Let's start to set up a proportion. Using the shadow was the key to this problem. When you're problem solving, you should always look for relationships. Okay, so I had the boys go out. They did a great job. They went ahead. They measured the shadow, and it turns out the shadow. So this shadow right here. I had the boys check it, and they came up with, we rounded a little bit, but it came up with 30 meters. Okay. Here's where I want to be very careful though about setting up my terms. Okay, so I have 30 meters here down at the bottom. I still don't know the height of this tree, so I'm going to use a variable, and we're going to call it x. Now, what to do? We've got one ratio, but a proportion needs two. It has to be equal to another ratio. If only there was something that I could measure the shadow of and that was safe to, just measure because it wasn't very tall. Oh, there is! I have a meter stick. I'm ready to set up a new ratio, and once I do, I should be able to figure out how tall this tree is without climbing it. Once we get this done, it probably won't give us an exact measurement, but it should give us a pretty good estimate of the height of the tree. Okay, great. So I've measured my shadow of the tree, and I've got my meter stick out, and so now I can set up my new ratio. All right, so I'll put that there, and it turns out that the shadow of the stick was 1.5 meters. And I want you to notice where I've put that in my ratio. I've been very careful to make sure that shadow goes with shadow and height of object will go with height of object. And I know the height of the meter stick. Guess what? When it's standing up straight, it is 1 meter. So now I have almost a complete proportion. There's just one missing element, and using the same techniques I did before with cross multiplication, a little bit of algebra, I should be able to figure out the height of that tree without getting killed. Okay, so now we're ready to solve this this proportion. So you'll remember that from the earlier example with boys and girls, all we have to do is do a little bit of cross multiplication. So let's start with my variable. I have 1.5 times x, which is going to come out to 1.5x. I'll bring down my equal sign, and then I'll cross multiply the 30 and the 1, and that's a nice easy one. That is 30 meters. Okay, I'm not multiplying the variables here. That was just the m's. That was just labels to show me what's going on. So then the next thing we have to do is separate this 1.5 from the x, and we're going to do that by dividing each side by 1.5. And of course, that means that 1.5 and 1.5 cancel out, and I'm left with x. And if I divide the other side by 1.5, I'm left with 20, and that should be something you can do in your head pretty easily. 20 meters in this case. If you don't like meters, you can figure out that 20 meters, what it converts to is feet. Siri just told me that it's 65.6 feet. That's a pretty big tree. I'm glad I didn't send my kids up there to measure it. Everything worked out well, thanks to proportions. So, we're going to be using proportions to solve a whole range of different problems in class. You can start to think about what kind of problems you can give to me to solve. And I think we ought to have a lot of fun with it. It's a really useful tool. Again, if there's anything that you didn't understand, come armed with questions tomorrow. See you guys later. Oh geez, one last thing before I go. I wanted to connect this to literature in some way. There's a great book in the library called The Librarian Who Measured the Earth. It's by Catherine Lasky. It's a true story about somebody from ancient Greece, and you'll find out all about who he was. He measured pretty accurately the diameter of the Earth using just a stick. And believe it or not, he didn't travel around with the stick just laying it end to end. He had a plan, and it involved proportions. It's a really great story. You should check it out. If for no other reason, then it'll show you just how smart the ancient Greeks were. Okay, that's it for now. See ya.